Okay, so I'm going to write down the more complicated sign. I'm going to tell the reader, proof. Write that down. Use that word. That's the beginning of my proof. Write down the more complicated sign exactly the way it looks. Hope I have enough space to do this. Wrote that kind of big up there. Make some change. Again, you never know what the best change is going to be. Sometimes it really is best to change everybody to sines and cosines. Just for fun, I'm going to do this one differently. Instead of changing everybody to sines and cosines. Remember, there are a lot of different possible things you could write up that are still correct. As long as every step is mathematically legitimate, it's still a good proof. As long as you start on one side and end on the other. I'm not going to convert that guy. I'm going to get a common denominator. I've got two guys here. I'm only supposed to have one in the answer. So let's add our fractions together. So my LCD would be sine cosine. This guy's missing a cosine. So I'm going to multiply top and bottom by cosine. This guy, to have sine cosine on the bottom, is missing a sine. So I'm going to multiply top and bottom by sine. Sine times sine would be sine squared. On the bottom, we'll get sine cosine. Okay, sine or secant times cosine, those are reciprocals. That's just 1. So these two multiply to 1. This is a very similar problem to the last one. So this is almost identical to the one we just did. Now I have a common denominator. I can write this as one fraction. One minus sine squared could also be written as cosine squared. Hey, I could cancel out one of those cosines. Get cosine over sine. Hey, that's just another name for cotangent. All right, let's do 2 more. Okay, this one's a little tricky. There's a trick to this that you probably wouldn't come up with on your own. So I'm going to teach it to you because somebody taught it to me. Proof. On these, it really doesn't matter which side you start with. A lot of them don't. That's an equal sign there. So I'm going to start with the left-hand side. Cosine of x over 1 minus sine of x. Put my equal sign and do something legitimate. Okay, so the trick with this, you have to think back to college algebra or intermediate algebra, rationalizing denominators. Or complex numbers. Remember multiplying top and bottom by the conjugate of the bottom? That's the game we're going to play. If you've got stuff that looks like this, 1 minus sine, 1 plus cosine, 1 minus cosine, anything that looks like that, here's a trick you could try that works a lot of times. Multiply the top and bottom by the conjugate of this guy here. So I'm going to multiply top and bottom by 1 plus sine of x. Not both sides of the equation. I'm not allowed to work with both sides. I have to start with one side and turn it into the other. Multiply top and bottom of a fraction by that. I'm allowed to do that because I'm doing it top and bottom. I'm going to leave the top factored. I'm not going to multiply that out because I've done this problem and I know it's better not to. But I am going to FOIL the bottom. So 1 times 1 would be 1. Outer would be plus sine of x. Inner would be minus sine of x. Hey, those will cancel. And for the last, we get minus sine squared of x. These two cancel out. So I'm recopying everything. On the bottom, I have 1 minus sine squared. Anytime you see 1 minus sine squared, that's cosine squared. If you see 1 minus cosine squared, that's sine squared. You're going to be using those Pythagorean identities on quite a lot of these. So one minus sine squared is cosine squared. Keep in mind what you're trying to hit. Kind of have this in your mind the whole time. I should end up with a 1 plus sign on top. See, I had that. See that 1 plus sign? He's been hanging out the whole time. I'm just waiting for this cosine to disappear. Somehow that's got to disappear, and I need to end up with a cosine in the bottom. Look, that's going to happen right here. This one cancels out one of those, and I get exactly what I said I was going to get. This is a legitimate proof. This is what your proof should look like. Okay, and for fun, I'm going to do this one 2 different ways. I'm going to do it the hard way and the easy way. And they're both perfectly legitimate. So here's the hard way. All right, proof. I'm going to need a lot of space here. So I told you that one thing you can do, one piece of advice, is convert everybody into sines and cosines. So I'm going to start with the left-hand side, try to turn it into this. That's my goal. So write down the left-hand side. If the first thing you write down is not one of these sides exactly the way it looks, your entire page is wrong. Okay, so I'm going to follow my own advice, convert everybody into sines and cosines. So 1 over tangent, that would be tangent flipped over. That would be cosine over sine. And then tangent would be sine over cosine. Equals, I've got 2 fractions here. The answer is only 1 fraction. Somehow these will have to squish together and become one single fraction. They have to. So again, look for a common denominator. Common denominator would be sine cosine. This guy needs cosine top and bottom. So cosine squared over sine cosine plus this one, in order to get that denominator, sine cosine. It's already got the cosine, he needs another sine, top and bottom, so he'll be sine squared. Okay, now I have the same denominator, so I can add these together. Cosine plus sine is 1. Okay, so now I've got a single fraction, and somehow I have to rewrite this guy to look like this. Okay, so I'm going to have to do a whole bunch of nasty algebra here to figure out how to get that. I've got a tangent in the bottom. Tangent is sine over cosine, so I need an over cosine here somehow. So maybe I could multiply top and bottom by 1 over cosine. One over cosine. 1 over cosine. See, then I can squish these two together, sine over cosine, there's my tangent. 1 over cosine is a secant, and this is another 1 over cosine. So I could rewrite this, everything is where it needs to be. I've got a 1 over cosine, another 1 over cosine, and that's all over sine over cosine. Which is that secant squared right there over tangent. I've run out of room, but tangent. It was really ugly. But it worked. This is perfectly legitimate. If you handed me this, I'd give you full credit. Just there was a lot of weird stuff figuring out how to get from here to here. To this particular one, maybe there's an easier way. Let's try this instead. So here's an easier way. Still legitimate. Let's just add these fractions together. So in order to have a common denominator, this guy here, I'll write out an extra step here. 1 over tangent plus tangent of theta over 1. Notice I've made a change. Whatever you write over here has to look a little different than this, but still be equal to it. My common denominator here would be tangent. So I need to multiply top and bottom here by tangent. Tangent times tangent would be tangent squared. Now I can combine those together, 1 plus tangent squared. Wait a minute. That was one of my Pythagorean identities. 1 plus tangent squared is secant squared. That's what I was supposed to get. I'm done. That is secant squared over tangent. That's what I said I was going to prove. That's what I ended up with. I'm done. So that's an easier version of that proof. Either one was perfectly legitimate. I could also, by the way, another legitimate proof would be writing all of this backwards, literally backwards. Start with this guy, write it like that, like that, like that, like that. Still perfectly legitimate.